Hello and welcome. You've stumbled upon the Sleepy Physicist, and I'm so glad you're here. Whether you're already cozy in bed or simply seeking a peaceful moment before you nod off, this time is just for you. This space is designed to help you unwind, a gentle haven of thoughtful curiosity where you can explore profound concepts without having to move. Tonight, we will embark on a journey into a world that is deep, silent, and strangely beautiful, the quantum world. Specifically, we'll start at the very beginning, the quiet space between particles, which may seem empty but is anything but. It is the void that contains everything. Now, a heads up, I've tried to make this as relaxing as possible, but there's a small chance you might find it too fascinating. If your mind begins to buzz as softly with wonder, that's not a bad way to drift into sleep. Before we begin, if this peaceful, scientific corner brings you comfort tonight, I would be so grateful if you could show your support with a gentle like or even a subscription. This helps the channel reach other tired minds who could use a little wonder before they rest. For those who want to go a step further and support this series, super thanks and channel memberships are now available. Your support helps me continue creating these calming science stories just for you. Also, if you feel like sharing, I'd love to know where you are listening from and what time it is for you. Every comment makes this small community a bit warmer. Now, if you'd like, close your eyes and let's start. Imagine the area between two atoms, not the atoms themselves, not their dense nuclei or their orbiting electrons, but the space separating them, the quiet center, the between. To our eyes, this would appear as nothing, but in the quantum world, nothing is never truly empty. It is potential, it is softness, it is the waiting unknown. You aren't floating in a rigid mechanical universe of particles. Instead, you're suspended in a field of possibilities. In this field, reality doesn't progress like a clock, it hums, it flickers and it wavers. Even the things you consider solid aren't solid at all. If you could zoom in far beyond what your eyes, or even the best microscopes can see, you'd find mostly empty space, a proton here, an electron cloud there, but between them, vast stillness. You might picture this space as a room illuminated only by candlelight. Shadows flicker and shapes are uncertain. You reach out your hand but you find no wall, no edge, only openness. Yet, this space isn't without structure. It's filled with tension. Not the tension of anxiety, but the tension of a held breath, a pause before something new unfolds. This is the realm of the quantum field, an invisible presence that fills the universe like a gentle mist. It isn't made of matter, it is the stage where matter appears. And it is never truly still, even in the most quiet, coldest vacuum. A place with no atoms, no light, no sound. Particles spontaneously pop into existence and vanish again. This doesn't happen because they were called into being, but because the rules of quantum mechanics permit it. The space between particles isn't dead, it's alive with constant fluctuations. You may have heard of the Heisenberg uncertainty principle. It states that we cannot simultaneously know both the exact position and the exact speed of a particle. The more precisely we measure one, the less certain we become of the other. That might sound frustrating, but in this stillness it becomes something beautiful. The universe isn't built on certainties, it's built on uncertainty. And from uncertainty, anything can arise. You can now rest in that thought, that maybe your own uncertainties are part of the same rhythm. That not having all the answers doesn't mean you're lost, it means you are part of a larger flow. Now, imagine this quiet field between particles extending far beyond your body, past the air, past the clouds, past the planets, and across the entire universe between every atom. This stillness is everywhere. It is the space between everything and the force that holds it all together. In quantum field theory, every particle you know, electrons, quarks, photons, is actually just a ripple in its own field. An electron isn't a tiny ball, it's a small tremor, a vibration in the fabric of the electron field. So when you hold out your hand, what you're really holding is a pattern, a region where fields are vibrating in just the right way to feel solid. And between those patterns, the space still hums. You might think of yourself as being made of particles, but it might be more accurate to say you're made of patterns, or songs in a stillness too small to see. The more we look into this space, the more it gives us mysteries instead of answers. Particles that appear only when we look at them. States that exist in superposition, being both here and there, spinning both clockwise and counterclockwise until they are observed. It's as though the universe doesn't finalize itself until we pay attention, as if it waits and then responds. You begin to see the space between particles not as an empty gap but as a potential, not as an absence but as an invitation. And as your thoughts quiet down, This idea begins to settle into your chest like a warm weight. You aren't made of solid things, you're made of uncertainty that holds itself together, a self suspended in stillness, softly buzzing with possibility. So tonight, as you drift further, let this space be a source of comfort. Let the silence between atoms carry you. Let the gentle uncertainty cradle you like a tide. And as you begin to let go, you might wonder what happens when something that starts as one becomes two. Somewhere in the stillness you floated through before, a shift begins. It doesn't crack or shatter or make a sound, it simply separates. Not like a broken plate or a cut ribbon, but more like a reflection forming in a pool of water. One becomes two, yet they are still one. This is the peaceful beginning of quantum entanglement. Two particles that emerge not just side by side, but born from the same event. They aren't just close, they are coordinated, like dancers who never need to speak. Whatever happens to one, the other knows instantly. Imagine a candle's flame flickering in a mirror. No matter how you tilt or turn, the image follows. But now, remove the mirror and find the reflection still there. That's the strange beauty of entanglement. You rest in this thought, curious but calm. How can something become two but never lose its oneness? What invisible, unbroken thread remains between them? In the first experiments, physicists discovered that when a pair of particles were created together, perhaps from a single photon splitting, they seemed to remain connected no matter how far apart they drifted. A measurement on one would reveal the state of the other, not later, not eventually, but immediately. If you imagine one spinning clockwise, the other must spin counterclockwise, whether they are centimeters or light, years apart. This challenges our normal understanding of separation, distance, and individuality. We are taught to think that if something moves far enough away, it becomes independent. But the universe quietly suggests otherwise. When one becomes two in the quantum world, it is not a parting, it is more like an unfolding, a petal splitting from the bud. Not lost, but expanded. And this is where the mystery deepens. Because neither of these particles knows in advance which way it will spin. It's only when one is measured, when someone looks, that the choice is made and the other instantly responds. You might think of it like two boxes, each holding a coin. You don't know if either coin is heads or tails, but when you open one box and see heads, you instantly know the other is tails. But this is more than just knowing. It's not that the answer was already there, hidden. It's that the answer seems to form in the moment, in both boxes at once. The choice, the direction. The spin, it arises not from the past, but from the act of looking. And yet, the other particle already knows. That's the part that bothered Einstein. He didn't like it. He believed physics should be local, meaning that no influence should travel faster than light. He called entanglement spooky action at a distance. Because how could one particle's measurement instantly affect another across the galaxy? But the experiments kept confirming it. This wasn't an illusion, it was real. And so you lie here between science and poetry, between logic and mystery. You let the paradox wash over you like slow waves. Maybe not everything needs to travel. Maybe some things are just connected. The bond isn't made of string or a signal, it's something deeper, a shared beginning. You might think about your own connections. Someone you once knew, someone whose life once intertwined with yours. And even now, years or miles away, when you think of them, you feel something, not proof, but a presence. In that way, entanglement doesn't feel so strange. It feels like something you've known all along, because when one becomes two, it's never a clean break. Some echo always remains. And here's another curious part: entanglement isn't fragile. You would think that moving particles apart or surrounding them with noise would break the link, but the connection endures. Experiments have entangled particles across vast distances, from one mountain to another or even between satellites in orbit, and still the mirrored responses hold. It's as if the universe doesn't care about miles, it only cares about the story those particles share. You breathe into that idea that your own life is made of shared beginnings. From your earlier selves to the people who shaped your thoughts, some connections don't fade, they just stretch. And perhaps somewhere out there, another version of you, another thought, another moment is still entwined with this one, still reflecting, still moving in step. You're not alone, not in this thought, not in your body, not in the night. The universe may be vast, but the space between things is never empty. It holds mirrors, it holds memory, it holds possibility. And as you drift deeper into the quiet, you carry this with you, that what begins as one can become two and yet still belong to the same breath. But what if those two parts, now separated, still speak to one another, not through space, but through something faster, something timeless? What if their conversation isn't carried by light, but whispered instantly across the stillness itself? Let's rest there for a moment, because in the next chapter, we'll step further into the dark and feel how this tangled connection stretches beyond sight, into the deep unknown, into a tangle in the dark. There's a kind of silence that isn't empty but full, like a forest at night, so still you almost forget how alive it is. That's the kind of silence we step into now, a place where particles are tied not by rope but by rhythm. Entanglement lives here, in the soft dark between things. Not the darkness of fear, but of mystery, the kind that wraps you in a quiet question and holds you there. Picture two particles born together and flung apart. One sails east, one drifts west, and neither turns back. But somehow they keep listening. No signal passes between them. No light blinks, no wave travels. And yet they know. A change in one reflects instantly in the other, not seconds later. Not after some tiny messenger arrives, but right away, as though space itself doesn't matter, as though the thread between them completely ignores distance. That thread is what we call entanglement, but thread is just a metaphor really, because there's no rope, no fiber, no actual thing connecting them. It's more like a shared breath, more like harmony. Imagine a piano with two keys perfectly tuned in resonance. Strike one, and somehow the other hums too. Not because of a string, but because they are part of the same deeper structure. This is the tangle. It doesn't twist, it doesn't pull. It simply exists quietly like gravity. You may wonder what keeps the connection alive. If these particles drift through space, past stars and magnetic fields and radiation, shouldn't the link unravel? And yet, it doesn't, not easily, not quickly. In fact, physicists have tested this over and over again. They've created entangled photons, tiny packets of light, and sent them across towns, cities, even into space. One experiment sent entangled photons from Earth to a satellite orbiting above, and even across hundreds of kilometers, the connection held. Nothing traveled faster than light, and yet, something changed instantly. The more they test it, the clearer it becomes. Entanglement doesn't behave the way we expect. It doesn't fit neatly into our ideas of cause and effect. It doesn't ask permission from space. It doesn't care how far apart things are. You lie still now, imagining that thread invisible, unbreakable, stretching from one side of the sky to the other. If a single choice here ripples there, what does that mean for everything else? Are we more connected than we appear? The mind likes clarity, it likes knowing that this caused that. But quantum mechanics often moves differently, not like dominoes, but like a chorus. Many parts singing in unison without a conductor, without a plan, and yet somehow the harmony appears. You may wonder, does entanglement allow communication? Could we send a message faster than light this way? And the answer, as far as science can tell, is no. Entanglement carries correlation, but not information. The result of one particle doesn't control the other. It only matches, like two dice rolled far apart, always landing with the same face up. You can't use that to send a message. But it still feels magical because the pattern defies randomness. It reveals something underneath, a structure not made of parts, but of relationships. It suggests that the universe at its root is not a collection of separate things but a woven whole. Not a machine with isolated gears, but a loom of interlaced events. And in this loom, threads twist together and split. Some remain entangled for a moment, others for lifetimes. Perhaps you've felt it too, that sudden sense of someone thinking of you right as you think of them. That call, that dream, that wordless recognition. Science doesn't call this entanglement, but your body doesn't always wait for science. It feels what it feels, and sometimes what it feels is closeness across distance. You breathe a little deeper, not because you understand it all, but because the mystery feels kind. There is comfort in knowing that separation isn't the end of connection, that even in the darkness between stars a tangle remains. Now, close your eyes and imagine the sky at night. Not the stars, but the space between them, the blackness, the velvet. That's where entanglement hums, unseen, untouched, and yet still real. And maybe if the universe itself is woven this way, then so are you. You're not made of one thing alone, you're a braid of memories, of molecules, of moments shared. And somewhere inside you, a tangle persists, quiet, silent, unbroken. So as you sink deeper into rest, let the mystery stay with you. Let the unseen thread carry you into dream. And ask yourself as sleep slowly comes, what happens when even time, the thing that divides before and after, gets tangled too? Because next we'll float beside a question that puzzled even the great Einstein, a strange effect, a whisper across time that he called spooky. And not all mysteries bring comfort. Some unsettle even the calmest minds. And for Albert Einstein, a man who craved elegance, clarity, and order, Entanglement was not beautiful, it was spooky. He didn't mean it as a compliment. To him, this strange behavior, where two particles appeared to coordinate without sending any signal, felt like a flaw, not a feature. It haunted the clean, clockwork vision of physics that he loved. You lie here now, wrapped in blankets, as he once sat wrapped in thought. Years before the modern experiments, Einstein already sensed something in quantum theory didn't feel right. He believed deeply in locality, the idea that an object is only affected by its immediate surroundings, that to influence something, you must touch it or send a message or cause a ripple that travels through space. But quantum entanglement seemed to mock this. Touch one particle and the other responds instantly, even if it's light years away. It wasn't just strange, it broke the rules, at least the ones Einstein trusted. He tried to fix it. In 1935, along with Boris Podolsky and Nathan Rosen, he proposed a thought experiment that came to be known as the EPR paradox. It argued that quantum theory must be incomplete, that there had to be some hidden variable, some secret rule we just hadn't found yet. Because surely, he thought, nature doesn't play dice. Surely there is order, even if we don't yet see it. You might imagine Einstein at his desk late at night, a cup of coffee gone cold, his pencil tapping slowly on the page. He believed in causality, in a universe that follows laws like steps in a waltz. But quantum mechanics didn't dance like that. It jittered. It flickered. It seemed to choose only when watched. And Einstein couldn't accept that reality needed an observer to become real. It felt too strange, too fragile, too spooky. So he hoped entanglement was a mistake, an illusion, a sign that our theories were close but not complete. And for a while, many agreed with him. After all, how could information travel faster than light? Wasn't that forbidden by the very theory he'd built, relativity itself? You breathe slowly now, feeling the tension between two truths. On one side, Einstein's longing for logic. On the other, the quantum world's refusal to be tamed. Decades later, in the 1960s, physicist John Bell would offer a way forward. He showed that if Einstein were right, if hidden variables truly guided quantum behavior, then certain mathematical inequalities would always hold true in experiments. But if quantum mechanics were right, if entanglement was real and spooky action truly happened, then those inequalities would be violated. It was no longer a matter of philosophy. It became a question we could ask with numbers, with lasers, with care. And in the years that followed, scientists tested Bell's inequalities again and again. In labs filled with shimmering precision, they measured photons, electrons, and atoms, and every time quantum mechanics won. The inequalities were violated. The spooky action was confirmed. Not a glitch, not a gap in knowledge, but a feature of the universe itself. Einstein's doubt didn't stop the truth, but it did shape how we reached it. Because without his challenge, without his refusal to accept a universe that made no sense, we might never have searched so deeply. You might find that comforting. Even doubts have value. Even questions that seem stubborn or outdated can lead us somewhere profound. Einstein wasn't wrong to question. He just saw the universe as something teedier than it is. But the quantum world doesn't mind mess. It allows things to be uncertain, to be both here and there, to be joined without wires, to be known without sending a word. And in that gentle defiance of clarity, you find a kind of beauty. You don't need to know every answer. You only need to be open to the mystery, like standing in a dark room and trusting the floor beneath your feet. Even if you can't see it, it still holds you. So, as you rest tonight, let Einstein's doubt linger like a lullaby. Let it remind you that even the brightest minds don't have all the pieces. And that's okay, because some questions are not meant to be solved in one lifetime. Some are meant to be held like a seashell at your ear, echoing something you may not fully hear but still understand. And as the quiet gathers again, you begin to wonder if this entangled connection defies even the speed of light. Then what happens to the very idea of time itself? Does it stretch? Does it ripple? Does it bend? Because next we'll drift into that mystery, the strange stillness behind even the fastest thing we know, light. Close your eyes. Picture a beam of light moving across the cosmos. It's fast, unimaginably fast, but still it takes time. Light from the moon takes a little over 1 second to reach Earth. From the sun, about 8 minutes. From the nearest star beyond our solar system, over 4 years. Even light, the swiftest traveler in the universe, is not immediate. And yet, entangled particles don't seem to care. One is here, one is far away, and still a change in one is felt by the other instantly. Not after a delay, not after light has time to carry a message, but now. This isn't just strange, it's a challenge. Because according to Einstein's theory of relativity, nothing, no influence, no information, no effect, can travel faster than light. The speed of light is more than a number, it's a limit, a law, a cosmic boundary. And yet, in the world of entanglement, it begins to blur. You drift inside that tension now like a feather between two ideas. One idea says, the universe is orderly, time-structured. The other whispers, sometimes connection moves outside that rhythm. The speed of light, roughly 300,000 kilometers per second, is fast enough to circle the Earth 7 times in the blink of an eye. It's how we see, how we communicate, how the stars reveal themselves to us. And for a long time, we believed nothing could beat it, that even thoughts, even influences, must obey that limit. But entanglement doesn't send messages, it doesn't transport signals. It simply exists. It's as though two particles share something deeper than distance. A kind of unified state that remains no matter how far they drift apart. So when one is measured, the other knows instantly. Not because it's told, but because it was never truly separate. You might think of two dancers starting in perfect sync. No matter how far they wander, when one lifts an arm, the other does too. Not because of a message, but because their rhythm began together, and somehow it never ended. This isn't faster than light communication, it's something more subtle. A shared beginning echoing through space. Physicists have tested this again and again, separating entangled particles by kilometers, by mountain ranges, even by the vacuum of space. They've closed every loophole they can imagine, and still, the coordination remains. You might wonder, is this a crack in the speed limit of the universe? Not quite, because as strange as it seems, entanglement doesn't violate relativity. It doesn't allow you to send a message faster than light, it only reveals the outcome of a shared quantum state. You can't control what the particle will do, you can only see the pattern after it happens. And that means there's no way to use it for instant messaging, no shortcuts, no cosmic telephone. Still, the effect is real, and it hints at something deeper. Perhaps speed is not the only measure of connection. Perhaps some things don't travel from A to B, they simply are in both places at once. You rest in that idea, letting it loosen your thoughts. Imagine two stars on opposite sides of the galaxy. Imagine two particles that once shared a moment now tied forever. And in that tie, a different kind of time exists, not measured by clocks, but by relationship, a timeless bond. In your own life, you felt something like it, a memory returning with no warning, a thought of someone just as they think of you, a moment that feels suspended outside time. The speed of light may be absolute, but feeling doesn't always obey absolutes. You breathe a little slower. You imagine what else might live in that instant, that place where cause and effect don't follow the old rules. Does time itself ripple there? Does it pause or fold or become something else entirely? Scientists explore these questions through quantum field theory, through mathematical models, through careful experiments. But here tonight, you explore them differently through wonder, through rest, through a slow unfolding. Because sometimes, understanding isn't about solving it, it's about sensing, feeling the weight of the idea without needing to carry it all. And here's a thought to settle into: if two things can be connected across space without delay, then maybe space and time are not as separate as they seem. Maybe they are stitched together in ways we're just beginning to glimpse. As you close your eyes more fully now, let that question echo gently: what if your act of noticing, your observation, your awareness is part of how the universe arranges itself? Because next, we'll enter a new chapter, where looking is not passive, where measurement is not neutral, where the very act of observing becomes part of the story. Imagine holding a snowflake in your palm. You want to study its shape, its delicate structure. But the moment you breathe just a little too warm, it melts. This is what it's like to observe in the quantum world. The very act of looking changes what you see. You lie still now, wrapped in blankets, and let that idea drift in gently that to measure something at the smallest scale is not to witness it, but to touch it. In the world of classical physics, the physics of falling apples and swinging pendulums, you can observe without altering. You can watch a ball roll and know that your gaze doesn't change its path. But in the quantum world, things are different. Here, particles behave like waves of possibility, not as fixed points, but as blurred clouds of potential. And it's only when we look, only when we measure, that the blur settles, that the cloud condenses into something definite. This is called wave function collapse, a poetic name for something both strange and essential. Before the measurement, a particle isn't in one place, it's in many, not spinning one way but all possible ways. It exists in superposition, a blend of possibilities. But when we observe, the possibilities fall away. One outcome becomes real, and all the others quietly vanish. You might think of a coin spinning in the air. Not just heads or tails, but both swirling, shimmering. Then with a glance it lands, one face up, one story chosen. Your attention, it seems, plays a role. Not like magic, not because you wish it, but because measurement at this scale is interaction. To look is to bump. To ask is to influence. Even the softest inquiry becomes a touch. And so in quantum mechanics, we find a curious loop. We need to observe to understand, but in observing we change what is. You rest with that for a moment, letting it ripple through you. It's not about control. It's about entanglement. Not between particles now, but between you and the world. You're not separate from what you measure. You are part of it, connected by the thread of awareness. In the famous double-slit experiment, light or electrons pass through two tiny slits and form patterns on a screen. If no one watches, the particles behave like waves, interfering with themselves, making ripples like water. But if you set up a detector, something shifts. The wave disappears. The particle chooses a path, and the interference pattern is gone. It's as if the universe waits to be noticed, then reshapes itself to match the question. You breathe that in, the universe reshapes itself to match the question. What questions do you ask without words? What things do you change just by noticing? Science doesn't say you create reality, but it does say you participate. You the observer. You the measurer. You the influence. Even without instruments, even without intention, your presence has weight. Your awareness is woven into the fabric of what happens. And so you rest in that understanding, not to control but to appreciate. Your gaze carries more than light, it carries meaning. It carries shape. In your own life too, you've seen this dance. The moment you reflect on a feeling, it changes. The second you try to hold on to joy or pain, it shifts. The act of observing always bends the thing being seen. You might think of your thoughts as quantum particles, soft, unstable, flowing until watched. And the more you try to pin them down, the more they slip into new shapes. Let them float. Let them move. Let them collapse only when they're ready. You're not here to force clarity. You're here to notice gently, to measure with kindness.